Circles are everywhere, from our toys to cars and even our houses. They're a shape that we see all around us, and it's not just for aesthetics. Circles have practical applications in various fields like HVAC, engineering, and agriculture. In this video, we're diving into the fundamental concepts of a circle, specifically the area and circumference, and how they can be applied to real-world scenarios. Understanding how math like this, that is used in our everyday lives, can give us a deeper understanding of the world around us and help professionals excel in their fields. But first, what is the area of a circle? The area of a circle is the region of a two-dimensional plane occupied by the circle. It can be determined by using the formula pi r squared, where r is the radius of the circle. What about the circumference? The circumference is the distance around a circle. You can calculate it using the formula 2 pi r. Now that we've covered the basics of the area and circumference of a circle, let's look at some real-world examples. HVAC. You've likely heard of it, but do you know what it stands for? It's an abbreviation that means heating, ventilation, and air conditioning. It's a subdiscipline of mechanical engineering that utilizes the principles of thermodynamics, fluid mechanics, and heat transfer. And one of the key areas where HVAC relies on is the use of circles. Why circles? They're more practical and efficient for the system. Circular ducts have less surface area compared to rectangular ducts, which means less energy is used and results in an efficient airflow. Now, when it comes to HVAC, calculations are crucial. Engineers need to fully comprehend what's happening, identify all relevant variables, come up with potential solutions, avoid flaws, and eliminate redundancies. And that's where the area and circumference of a circle comes in. It helps engineers plan and find the needed area or size of a duct to be effectively used in HVAC. It also helps them in finding the airflow rate, which ensures the optimal flow rate required in buildings. In short, understanding the area and circumference of a circle is vital in designing HVAC systems that are efficient and cost-effective. Engineering. In this branch, there are a lot of applications of using areas and circumference of a circle. Areas and circumference of a circle can be applied in gears that are part of mechanical engineering. Gears are used to transfer motion and torque between machine components in mechanical devices. So sizes do matter when it comes to that. Engineers can use the circumference of a circle as part of the actual formula to measure the size of a gear and the gear ratio. The use of sizes of gears can be crucial since gears of different sizes can be used to increase the power of a turning force. Given that gears are circular and thus follow the principles and properties of a circle, the absence of the circumference would severely restrict engineers' ability to design and analyze circular components and systems. Lastly, agriculture. Even circles can be used in agriculture. One example of it is the use of circular fields or crop circles. Crop circles are a result of center pivot irrigation, an efficient method for water conservation in agriculture. This works by consisting of a single long irrigating pipeline attached to a central tower that moves slowly over the field in a circular pattern and irrigates the plants with sprayers or sprinklers that are placed on it at frequent spacing. The single long irrigating pipeline acts as a radius that revolves around its center. The radius of the pivot can be adjusted depending on the size of the field and the crop being grown. By knowing the radius of the pivot, farmers can calculate the area of the circular field being watered and adjust the amount of water being applied accordingly. Farmers must also know the area of land available for farming. for them to know its size for budgeting and cash flow needs. Many commercial farms are mapped using satellite mapping systems, but smaller farmers can't do this. They have to work this one out using the resources at hand. So using the formula for the area of a circle to solve for the area of a circular field would be convenient. This concludes today's video. I hope you've learned more about the area and circumference of a circle's real-world applications. Please take a look at the description for the citations. Thank you for watching!